In this section, we're going to expand upon what we learned in the last section. Remember, in the previous section, we had a system of linear equations. We had typically two equations and two variables, x and y. In this section, we're going to jump to three variables and have three equations in x, y, and z. Now, remember in the last section, we talked about geometrically what a system of linear equations and two variables meant. And so here, what does it mean to have a linear equation in three variables? For example, x plus y plus z equals 5. Well, the graph of that in 3 dimensions is a plane. So if you have three equations in three variables, you have three planes. Now, how can three planes intersect? Well, they can do it lots of ways. For example, if you had three parallel planes like this, they don't intersect at all, so there'd be no solution, right? We're looking for points x, y, z that satisfy all three equations. You could have a plane like this, and a plane like this, and another plane like this, and so any two would intersect, but all three wouldn't, and so that would be no solution. So if you look on page 493 in the text, you can see the different pictures of how three different planes can intersect. So you can either get a single point, so that'd be a single solution, an ordered triple. You can get a line, three planes can intersect in a line, like this, and then one on top, so they intersect in the line. A plane, yeah, if you have all three planes on top of each other, the same plane, you'd have an infinite solution. Or no solution, okay? And there's several different ways to get no solution depending on how the planes compare to each other. And just like in the last section, we're not going to focus on the infinite solution. We're really looking at the no solution and the one solution. Right? So what's the procedure for solving a system of linear equations, three linear equations and three variables? Well, what you do is pick two equations and eliminate one of the variables, just like we did in the last section. So, for example, suppose you take two equations and eliminate x. Now pick two other equations. Now, one of them you're going to have to reuse if you have three equations. So, say you use the first two equations and eliminate x, and then you use equation 2 and 3, and you eliminate x. Well, now you have two equations in two variables, and now you're back to the previous section. So it's really just one extra step here. So let's do an example. So the first example has this system. It's a system of three linear equations and three variables. Okay. So what we want to do is eliminate one of the variables first. And it's nice to look for things that are multiples of other things, right? Because you're going to wind up using all three equations here. Again, like for example, you could use the first two, 1 and 2, and then use 1 and 3. Or you can use 1 and 2 and 2 and 3, for example. Okay? So I probably wouldn't try to eliminate the z in this problem because you have a coefficient of 3 and 8 and 18, and one's not a multiple of the other. I mean, you could do it, but you'd have to multiply the first equation, say, by 8, and the second equation by negative 3 to get the z's to be plus or minus 24. That's just extra work. Notice to get rid of y, you can use the first and the second and multiply the first by negative 6 to get rid of the 6, and then use the first and third and multiply the first by negative 8 to get rid of the 8. So that's not as much work as the z's. And what about getting rid of x? Well, these two already have a 2x, so you just have to multiply one of them by negative 1 to get the negative 2. And then the 2x and the 6x, you're off by a multiple of 3. So that's not hard either. I guess I'll just stick with the x's. Okay, so I'm going to use equation 1 and equation 2. Again, I'm going to write a little code. Just in case you make a mistake, it's a good idea to do this. You can go back. So I'm going to write equation 1. 2x plus y plus 3z is 1. Again, my z's have a hash mark through them. My 2's do not. And then I'm going to take negative 1 times equation 2. Okay, so negative 1 times that, so negative 2x minus 6y minus 8z is negative 3. And again, the goal is to get coefficients to match but be off by a minus sign. So I left the first equation alone. I multiplied the second equation through by negative 1. So negative, 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 negative. Okay? And now add. The goal was to get rid of the x's. So 2x minus 2x is 0. Y minus 6y is minus 5y. 3z minus 8z is minus 5z. And 1 minus 3 is negative 2. Okay? So now I have an equation. I've eliminated x. Okay, now I use the first two equations to eliminate x. Now I need to use two others to eliminate x. I guess I'll use the first one and the third one. Okay, so I'm leaving this for now. So let me write, I'm going to write the equation 3 down here. 6x plus 8y plus 18z is 5. And I'm going to multiply the first equation times -3 because I'm trying to get a -6 for x. So if I multiply the first equation times -3, I get -6x minus 3y minus 9z is -3. So let me check myself. So there's my third equation I wrote down. -3 times the first is -6x minus 3y minus 9z is -3. Okay, so now I have my x's match except for the coefficients match, but they're off by a minus sign. So when I add, this x drops out, I get 5y, 18z minus 9z is plus 9z, 5 minus 3 is 2. Okay, so now I have two equations and two variables. I have this one with y's and z's and this one with y's and z's. So again, you want to eliminate the same variable here that you did here. So now you have an equation in y, z, and an equation in y and z. All right, and you might want to label, call this equation 4 and call this one equation 5. Right? So now I'm back to the previous section where we had two equations and two variables. And notice we got lucky, this one's just set up perfectly. I have a 5y here and a minus 5y here. I don't have to do any adjusting. So if I put equation 4 here, minus 5y minus 5z is -2. And equation 5 here, 5y plus 9z is 2. All right, let me check my work. Okay, and now when I add, I get 0. 9z minus 5z is 4z, and -2 plus 2 is 0. And so if you divide both sides by 4, you get z is 0. Now a solution to the system of equations is an ordered triple xyz. Okay, that satisfies all three equations. So just getting to z equals 0 is not the end of the problem. Right? We have to figure out x and y as well. Well, once you have z, don't go back to the original. Right? Go back to one of the equations you have with two variables, because if you plug z equals 0 into either one of these, you can figure out y. Right? So I'm back substituting now. So for example, 5y plus 9z, z is 0, is 2. I'm plugging into here. So 5y is 2, and y is 2/5. And if I'd plugged z equals 0 in here, I would have gotten the same thing for 2/5 for y. Okay, so now I have z and now I have y. Now go back to the original and just pick one of them. I think I'd pick the first one because the numbers are smaller. Plug in z, plug in y, and figure out x. So I'm using equation 1 here. It doesn't matter which one you use though. So 2x plus y plus 2/5 plus 3 times z, z is 0, is 1. 2x plus y plus 3 times z is 1. Okay, so it looks like I get 2x plus 2/5 is 1. If I subtract 2/5 from both sides, I get 2x is 3/5. Right, 1 is 5/5. 5/5 minus 2/5 is 3/5. Multiply both sides by a half, you get x is 3/10. So my solution is 3/10, 2/5, oops, and 0 for z. Okay, now again, if that is a correct solution, it should make all three equations true. Let me do a quick check. Now z is 0, so that's easy. So 2x, that's 6/10. That's 3/5 plus 2/5 is 1. Okay, it works there. And then 2 times x, again, that's 3/5 plus 12/5 is 15/5, which is 3, right? Again, z is 0, I'm not doing that. And then 18/10 is 9/5, and 16/5 is 25/5, which is 5. It's correct, it works. Okay, so again, and if you're going to check, make sure it works in all three. You may get an ordered pair that works in the first two and then doesn't work in the third. So, which means you probably made a mistake somewhere. So, especially if one of your answers turns out to, one of your coordinates in your solution turns out to be 0. That's a common thing where it works in two and not the other. You probably made a little mistake somewhere. Okay, so that's the first example. Let's look at the second example over here. I've written over here. Okay. So we have, again, 3 equations and 3 variables. Okay, so let's sort of think about how we want to approach this problem. So we want to eliminate one of the variables first. Now, if you look closely, the last equation doesn't have a y in it. It's already gone. So I think a good strategy is maybe use the first 2 equations to eliminate y. That's going to save you some work. Okay, so the first example I did, I purposely picked one where it wasn't simplified like this to teach you the general procedure. But now that you know the general procedure, you should look ahead and see if you can save yourself some work. Like on the last one, I looked at the coefficients to see which one was easier to get rid of. Here, y is already gone in the third equation. So let's eliminate y using the first 2, and then we'll right away have 2 equations and 2 variables. Okay, so this is equation 1, 2, 3. I'm using 1 and 2 to eliminate y, and notice it's already tailor-made for us. So equation 1 is x plus y plus z is 7. Equation 2 is 2x minus y plus z is 9. And I didn't have to do any adjusting because my coefficient of y is plus 1 and minus 1. They're the same coefficient but off by a minus sign. So if I add, I get 3x plus 2z is 16. Okay, so I'll call that, say, equation 4, because that one's over there is 3. Okay, so now I have 2 equations and 2 variables, so equation 3, well, here, let me be careful. I have to look and see what I want to eliminate. So I have a 3x plus 2z is 16 and a 3x minus z is 10. So if I just multiply one of them by -1, the x's will be opposite signs. Okay, so I'm going to put equation 3 here. 3x minus z is 10. And I'm going to take the -1 of equation 4. So negative 3x minus 2z is negative 16. Okay, so 3x minus z is 10. Negative 3x minus 2z is negative 16. It's not a bad idea to sort of check as I'm doing as you go, because you drop a minus sign and all bets are off. And why waste your time going through all that to realize you made a mistake? So if I add down here, that's 0. Negative z and negative 2z is negative 3z. And 10 minus 16 is negative 6. Divide both sides by negative 3, and I get z is 2. Okay, now we have to go back and find the other variables. And again, when you're plugging z back in, don't go back to the original equations 1 and 2 where you have 3 variables. So I would either plug the 2 back into equation 4 or go back to equation 3. So I'll just use the original equation. So I'm plugging in z is 2, so 3x minus 2 is 10. Okay, I'm plugging z is 2 back into the third equation here. So 3z is 12 and z is 4. Okay, whoops. I wrote it down wrong. Let me do that again. Sorry, I'm 3x. 3x minus 2 is 10. I said z, and so I wrote z. 3x minus 2 is 10. So 3x is 12 and x is 4. I said z is 4 and I already had found z. Okay, so now I have z and x. We just have to go back to one of the original equations, 1 or 2 with 3 variables. Let's just use the first one, right? X plus y plus z is 4. So x plus y is 7 plus z is 7. X plus y plus z is 7. And so 6 plus y is 7. And it looks like y is 1. So what's my final solution? X is 4, y is 1, and z is 2. All right, let's see if that works in all 3 equations. X plus y plus z is 7. 4 plus 1 plus 2 is 7. 2x, that's 8, minus y is 7, plus 2 is 9. And 3x, that's 12, minus z, 2 is 10. That's great, it works. Okay, so we have a solution again. Okay, well, that wasn't too bad. But see, you can save yourself a little work by looking ahead. Okay, now let's look at our last example. okay, which says 2x plus y minus z is 7. X minus 2y plus 2z is negative 9. And 3x minus y plus z is 5. X minus 2y plus 2z is negative 9. 3x minus y plus z is 5. Okay. Okay, so let's look ahead. Try to look ahead. Is there one variable that looks like it's easier to eliminate than one of the others? Yeah, I mean, they're all about the same, because you could use the x to get rid of the 2 and the 3 pretty easily. Here, the y's are easy, and you could double one of them to get rid of the 2. Here, the z's already match, and you could double one of them to get rid of the 2z. So it doesn't look like any one is easier than the other. Just to be different, let's use the z's. Let's do the z's. All right. So I have a negative z and a z. So let me just recopy those. Equation 1 and equation 3. Equation 1 and equation 3. So if I add, I get 5x. Now look what happened here. I got a 0 and a 0. The y's and the z's dropped out. I got 5x is 12. Interesting. And divide both sides by 5. You get that. Now, to be honest, I wasn't even looking at the y's and the z's. I was just looking at the z's, trying to eliminate those, and those dropped out, but then so did the y's. So we immediately got x is 12/5. Now, what do you do in this situation? Because in the previous examples, I said, well, once you get one of them, plug it back into one of the equations with 2 variables to figure out the other variable. But I don't have a situation like that. So what do you do when something like this happens and we get, x is 12/5? Well, what you do is just pick 2 of the equations, plug 12/5 in for x, and then you'll have 2 equations and 2 variables, and you can solve for the other 2. I guess it doesn't really matter. I'll fill it back. So I'm going to plug the 12/5 in the first equation and the second equation. So I'm plugging 12/5 in here. That'll give me a number. You can subtract it from both sides. You'll have a y and a z. And if I plug 12/5 here and subtract it, then I'll have a y and a z here. Okay. So let me plug the 12/5 in for x here. So 2 times 12/5, that's 24/5. This is equation 1 here. Plus y minus z is 7. So equation 1 here. So y minus z is 35/5. That's 7 minus 24/5. So y minus z is, what is that, 11/5? Okay, so that's my new equation 1 with the x is 12/5 plugged in. Let me do the same thing for equation 2. So I'm putting 12/5 in for x. So 12/5 minus 2y plus 2z is negative 9. So negative 2y plus 2z. I'm subtracting 12/5 from both sides. So fifths, that's negative 45/5. That's the minus 9. And then minus 12/5. So negative 2y plus 2z is negative 57/5. Okay. Okay. So now I have a new equation 1 and equation 2, but notice there's no x. All right. So this one, the order is a little different. We got rid of 2 variables in one fell swoop. We were able to solve for x, but we don't have an equation with x and y that you can plug in x and get y, or x and z, you can plug in x and get z. So what do? Just plug x into 2 equations. Now I have my 2 equations and 2 variables. So if I take this equation here, negative 2y plus 2z is negative 57/5, and then multiply this equation through by 2, because I'm trying to get the y's to match but be off by minus sign. So 2y minus 2z is 2 times 11/5 is 22/5. Okay, so I recopied this one. I multiply this by 2, 2, and 2. So notice when we add here, what do we get? Negative 2y and 2y is 0. Negative 2z minus 2z is also 0. And then negative 57/5 plus 22/5 is negative 35/5, which is negative 7. And you see we have a problem. So the idea is that we assume there is a solution to this, so and we're trying to find the solution, and we ran into a problem. 0 is not -7. Again, if you get 0 equals 0, that's nothing. That's not a problem. 0 is equal to 0. Okay, just because all the variables drop out doesn't mean there's necessarily a problem. But so 0 equals 0, you just have to go back and figure out what's going on. But 0 equals -7 is definitely a problem. That doesn't make any sense. So the conclusion here is there's no solution. Okay, so these are three planes that there's no point that lies on all three of those planes simultaneously. So we did 2 examples with one solution, we did 1 example with no solution, and again, the first problem taught you the general procedure. Okay, pick 2 equations, eliminate a variable, pick 2 equations, not the 2 you already picked, eliminate the same variable. Now you have 2 equations and 2 variables, you're back to the previous section. And in the second example, one of the equations already had one of the variables missing, so we use the other 2 equations to eliminate the same variable and continue from there, so it's a much shorter problem. And here what happened is we were trying to eliminate one of the variables and 2 of them dropped out. So we got one answer, a value for one of the variables, x. But we didn't have an equation with 2 variables to plug back into, so what do you do? Take the x, plug it in for x in one equation, plug it in for x in another equation. That will give you 2 equations and 2 variables, and now you're back to the previous section. Okay, so that's section 7.3.